Waiting for the signal. Waiting for the signal. Good. All right. Hello, everyone. Everyone have a good lunch? Yeah? Cool. Found some good food? Cool. All right. Good to hear. So welcome back. For this session, we'll be going over running your first server. Well, maybe your first. I don't know what you did before here, but we'll assume you have not yet. All right. So this session is going to be about an hour. We will go over the ideas of things first, and then we'll go into building them together. Sound good? So be ready. Hopefully, some quick housekeeping. From these setting up your project workshop, I realized that was not as complete because it really should have been a 1 hour session instead of a 30-minute session. So we created a template on GitHub. So if you go to the Discord, I sent a link to a project. You can use that to help set up your first project. And that's what we're going to use as a base for working in this one. So make sure that your project directory is similar to that base directory that I linked in Discord. Okay? Everyone got that? Cool. All right, so what are we going to do today? So first, we're going to cover what even is a server. Okay? I know that Dennis touched on this a little bit in his How Websites Work section, but we're going to go into a little more detail. Then we're going to go over the framework that we're going to use for this. We're going to use FastAPI. Okay, there are many, many different frameworks to build backend servers, but we're using FastAPI because it has a much easier separation for the way we want to teach you things. It is not necessarily a better system. It is just what works for this situation, which is how you should generally be choosing your tools, right? It's very rare that any one tool is. I'm going to get off my soapbox. Sorry. Okay. And then we're going to go over data formats. We're going to go over ASGI and Uvicorn. We're going to talk about ports. We're going to go back into the networking stuff a little bit. And we're going to end with going over processes and workers and configuration. Okay. So first off, what is a server? Which of these is a server? The left one? Yeah, the left one, yes. What else is a server? The right one. That is also a server. All of them are servers, right? Now you might be thinking, what the hell, a phone is a server? And yes, it can be. So then if all of these can be a server, then what the hell is a server? Are you ready for the secret? A server serves. That's it. If it serves some kind of content, it's a server. Congratulations, okay? So your phone probably has server processes on it to serve other processes also on your phone. It's a little trippy, but we'll get into that a little more in a minute. So a server serves requests, okay? A server can be hardware, can be software. Sometimes server is honestly kind of a terrible term because sometimes when we say server, we can mean the software process running on a computer, or we can also mean the computer itself, and it's not always clear. So sometimes people may clarify it with the server process, which is a process running in the software, or the server host, which is like the physical computer, or could be a virtual computer, but whatever, okay? Technically, you don't even need a network to run a server, okay? So for the later sessions, we have the prerequisite that you have to install like Docker Desktop or Rancher Desktop. Did anyone install those? Oh, awesome. Thank you, guys. Surprise, that's a server. When you actually run Docker things, when you learn this, you'll learn that you use the command line to do Docker stuff, right? But when you type those commands on command line, those commands aren't doing anything except sending a request to a server running on your computer. So it's one process on your computer, just making a request to another process on your computer and it responding to that request. Yes, it's all on the same computer, but it's still a server, okay? So the main things that define a server is that it's long-lived, right? So at least more than a couple seconds, right? It's not just a start-stop process. And it listens for requests to respond to and serves responses to those requests. That is a server, okay? Also, for a server to be useful, usually it needs some kind of well-defined protocol. In this case, we use protocol to mean a common way of communicating, basically a data format that we'll both understand. In the case of web servers, which we're largely talking about in this bootcamp, that protocol is HTTP, okay? Now, I do recommend reading up on HTTP. It's actually a very simple format. Don't read the specification definition itself, because those things suck to read. But you can find really good summaries of HTTP and how it works. It's actually a very simple two-part protocol. It's all plain text. But I do recommend reading up on it. And then it's also important because when you have a front end and a back end, they need to communicate along the same protocol so that they can understand each other. And that is what makes complete web applications, okay? So the front end server serves like web pages, the stuff you see, and the back end server serves the data, okay? Does that all make sense so far? So what does the server do? Excellent, very simple. All right, so let's illustrate that a little bit, right? So, and this is a slight repeat of Dennis's session, but it's very important to make sure everyone understands. This is a very common web application architecture, okay? Where a user will visit a website and some front-end server will fulfill that request, okay? And then it may make a request to the back-end server to get some data, right? So the front end, so let's say real quick, let's go to naver.com. Whoa, this is the wrong browser. Yeah, there we go. So nope, that's the wrong one too. Where is it? There we go. So let's say we go to naver.com, okay? And God, I hate this. Sorry, I have feelings about Naver, but I'm not going to get into them. So like this stuff is largely static, right? So this stuff would be included in the front end, right? This is stuff that there's code specifically defining how this should appear and all that. But then these down here, right? These are going to depend on the requester. I don't use this browser on Naver. I have no idea what this stuff is. I don't even know what all that means. But anyway, this came from the backend server. And then the front-end server, using the data from the backend server, figures out how to put it on the page and how to make it look. But as for which image shows here, which text shows here, the order they appear in, that all comes from the backend server, because the backend serves data, okay? And the front end just serves, you know, there's a button here, there's a box here, right? And then when we get data, we should style it this way. Does that make sense? That's kind of the separation between front end and back end. It'll make, if it's not 100% clear, it'll get a little bit more clear when we get into the kind of the data exchange. Why did you stop? I didn't want you to stop. Right. So going back to kind of the separation of concerns between front end and back end, the key thing is that the front end shows how to display things, but the back end has what we call business logic, okay? The rules that define how data should be manipulated, okay? This is the business logic. And the business logic is why software is written, okay? It honestly took me a while to figure this out early in my career, but like software is written for people, right? We don't write software just to do cool stuff. I mean, we kind of do, but the purpose of software is to serve people. And we serve people through some kind of business process. Maybe not business process if you're like a nonprofit like CodeSeoul, but there are certain rules for how data should be exchanged with the user. And this is what the backend controls, okay? This is why backend is considered so critical. This is why backend has a lot of focus in like architecture and all these kinds of things, because this defines how the business runs from a software perspective, okay? And the goal is, when we're building all these systems, right, there's a lot of technology to make all of this work, right? There's like the physical server, there's Python itself, there's like the different frameworks you're using, all this kind of stuff. when the goal is really to just get the business logic working, right? So we as in like the software community, build tools to help us do as little technical stuff as possible so we can focus on the business logic, okay? Because that's how we get paid and how we can eat nice lunches like we just did, okay? So to that end, there are frameworks to help us build backend services faster and easier, because you don't want to have to like, open up a socket on the computer, set up the socket with the right flags so that they communicate along the right networks, format your request according to the TCP protocol, format your request according to the HTTP protocol. You don't want to do all that, right? You just want to say, send request, get response, done, right? So we have backend frameworks like Fast API that we use to do a lot of this work for us. Okay, now Fast API is one of these web frameworks to help us do that. And it allows us to build backends in a very structured way, a very easy way, where we don't have to think about all the little details, okay? It does a lot of stuff for us. Now, you'll hear programmers talk about magic, okay? When we say magic, we mean that there's some code that does a whole bunch of work, and you don't know what that work is, you don't understand what that work is, but it does stuff. We call that magic, okay? Now, we chose Fast API for this bootcamp because it does have magic, but just a little bit of magic, not a huge amount, okay? Because we want you to understand what's happening so that you understand how things are being built, okay? There are other frameworks. If you want even less magic, there's something like Flask, or if you want more magic, there's something like Django, right? But we went for a middle ground because we had to balance having minimal magic while still being able to actually finish the bootcamp in 40 hours, okay? So we went with Fast API. It is 12-factor compliant, which we'll cover in the next session. It does have dependency injection, which we're going to cover in a session tomorrow. Now, it does not do databases for you, okay? And this was an explicit choice by us, okay? Other frameworks like Django do handle the database for you, but we wanted you to handle the database directly for this, okay? And then also it auto-generates your documentation. This is awesome. That's like one of my favorite features of Fast API, because when you're working on a backend, you're not doing it alone, ideally. There's a front-end team that you're working with, and they need to be able to understand what data your backend server has and how to get it. How do they understand that? Through documentation. Do you want to write documentation? No. No one wants to write documentation, right? So this auto-generates some amount of documentation for you, which is great. And then you can also add much more documentation as you please, but that's going to be out of scope of this. And then it is ASGI compatible, which I'll explain in a few minutes. And it is blazingly fast. If you will, yeah, there we go. I see a couple laughs here. So you'll find that as you learn about more and more backend frameworks, all of them will say, we're blazingly fast. It's like, it's a meme. It's everything says they're blazingly fast to like, as a marketing thing, and now it's just a joke. If you see a framework say it's blazingly fast, don't take it seriously. So yeah. Oh, I had a joke on here, but I'm not going to do it. So now that we know what kind of server we're going to build, right? How do we actually exchange data with the server, right? I talked earlier about needing a well-defined protocol. So the protocol we use is HTTP, right? But what are we sending over HTTP, right? If it's a front-end server, we're sending web pages, HTML, CSS, JavaScript over HTTP, right? But when it comes to a backend server, we're supposed to be sending data for the front end to use to make things pretty, right? So how do we send that data, right? Do we send a bunch of ones and zeros? I mean, technically, yes, but we want to be able to read it, right? In case there's some kind of problem. So there's a few different formats of data that can be exchanged between a front end and backend server. Sometimes a backend server will just send HTML to the front end and just be like, hey, just render this, right? Although that's much less common these days. Or what is most common is they will send JSON. JSON is short for JavaScript Object Notation. Who's heard of JavaScript? Okay, where do you use JavaScript? Front end, yes. So that's one of the key reasons why JSON has become so popular, because JavaScript is used on the front end, and it's JavaScript object notation. JavaScript natively understands this data format, okay? And this right here is an example of some JSON, okay? It's also quite compact, right? There's not a huge amount of extra stuff that we don't need, but it's also easily read, right? So this is some JSON object. It has 3 fields, 3 keys: crust, toppings, and status. The value for crust is original. Toppings has 3 values: cheese, pepperoni, and garlic. And then the last value is a status, and the current status is cooking. You can all look at this and understand that pretty intuitively, right? But there are other data formats. There's also XML, which is long. It's very verbose. It's basically HTML, but as a data exchange format. And there's also SOAP, which if a company is like, we use SOAP, run, just run away. I mean, not really. There are some cases where SOAP actually makes a lot of sense, especially in some security contexts. But it's some old tech. Like, we were using SOAP at the beginning of my career, and I guarantee you I'm older than you think I am. So most places will use JSON, okay? Now, how I mentioned earlier about having a well-defined protocol between the client and the server. How do you do that? Part of HTTP has headers, okay? And that's something you can read up on your own. But one of the important headers is the content type header, okay? And that says what the data content is in terms of format, if it's JSON or XML or whatever, okay? Questions about the data formats? Cool. All right. I promise we're going to get through this and then we can actually write some code, okay? So, ASGI and Uvicorn. ASGI is short for Asynchronous Server Gateway Interface. You do not need to remember that. It's not important. But who knows what async is? No shit. Oh, that's great. That makes this way easier. Okay, better question. Who does not know what async is? Okay. Okay, cool. So we'll review it real quick. Async is this idea where you can request something, or some work can start, and it can end later, and you may or may not just wait for it to end. Okay? So, for example, let's say I'm a pizza chef, okay? And I'm cooking pizzas all day long. And you give me an order, right? I'm not going to stop everything I'm doing, do your order, give you your order, and then go back to what I was doing, right? I'm going to kind of add it to my queue of orders that I have to do. I'm going to finish cooking my order. And then when I finish your order, I'm going to send off your order and be like, hey, it's done. And then I'm just going to keep going. Okay. That's kind of an asynchronous way of operating, right? So, and this diagram here kind of describes it, right? So process A sends a request to process B, but process A keeps doing whatever it's doing, right? And then whenever process B gets that response, then it can decide whether to respond to it now or later. Does that make sense? A little bit? Not really? Okay. So basically, in most programming, right, when you write a line of code, you write that line and you expect the computer to run that line of code. And then when that line of code finishes, it'll move to the next line of code, right? That is normal programming. That is synchronous programming. It happens sequentially in time, right? Asynchronous programming, you can say, hey, maybe there's this async function. Run this function now. But then you don't wait for the function to finish. You just keep going. And then later you can say, oh, hey, remember that function I called? Now I want to wait for the response of that function. And then if the function's already done, you're just going to get the output of the function immediately. Or if it's not done, your program is going to pause until that function does finish, right? And the reason for this async programming is for speed, right? Because let's say you have 10 functions you need to run, right? They don't depend on each other. They can be run in any order, right? You just fire off all 10 functions. And then you just, when you need all those functions output, then you just say, okay, I'm going to wait until all 10 functions finish. And then when they finish, then you can continue on your way, okay? So in this way, it's a way to basically parallelize programming. Now, when we talk about async, Do not confuse async with multi-threading, okay? Who knows what the GIL is, the global interpreter lock? Oh man, I can be useful. Okay. So in Python, the global interpreter lock, although if more advanced people are in here, I know that they were talking about changing it, but to my knowledge, it hasn't happened yet. So correct me if I'm wrong. But at least to my knowledge, the global interpreter lock only allows one thread in Python. Okay. Now Python has a multi-threading module, right? So you're like, Beej, what the hell are you talking about? Of course Python has threads. They're not real threads. Okay. What Python does is when it has, it has a single thread where it's like, oh, I have multiple threads. Oh, I'm going to work on this one and that one and this one and that one and this one, and it just keeps basically swapping back and forth. Is that not true anymore? Or, okay. So that, at least that's how it used to be. I'm not sure about it anymore because they were talking about fixing or changing the global interpreter lock. I'm not exactly sure. It's been a while. But the way that Python got around this was through that kind of swapping, right? Which is really fast because a lot of times the things that slow down a program are when you're either reading from disk or reading from network. And those two operations, the CPU is not doing anything. Okay, it's just waiting for the data to be read from the disk or waiting for the data to come through the network buffer, right? So your CPU is just chilling. So that means your CPU can be doing other work. And that's where this kind of asynchronous work becomes useful, okay? So what the hell does that have to do with servers? Well, which is going to be faster? Your server stopping and waiting for every single request it gets, or your server working on each request simultaneously, and when it makes calls out to the database or makes calls out to the disk, it's just working on another request while it's waiting for that response. Right? The async method is going to be much faster. It can handle more requests and more responses faster. It's a performance thing. Okay. So ASGI, okay, is a way for Python servers to run in this asynchronous manner to get more performance without adding too much more complexity. Why does it not add too much more complexity? Because they have abstracted it away from you. You don't have to worry about it, okay? The ASGI server software does this for you, okay? So the ASGI server is the actual server part. I have to apologize. FastAPI is not actually a server, okay? What it does is it actually does a lot of the business logic for you, and it connects to a server. Okay, the ASGI part is the actual server, and then FastAPI sits on top of it. Now we're getting into the weeds a little bit. In practice, that's not too useful a distinction, but you need to understand at least why this kind of stuff happens, because you can't use FastAPI alone. FastAPI uses another library called Uvicorn, okay? And Uvicorn is the actual ASGI server, and then FastAPI sits on top of it. Does that make sense? Cool. So Uvicorn handles all this kind of like rapid swapping stuff. And FastAPI is just like, I got a request. Let me do some work. Here's the response. Okay. And then Uvicorn just kind of takes those parts and arranges them so that you get the fastest throughput. Any questions about that part? I either did so well that everyone understands it, which I seriously doubt, or so poorly that people don't even know where to start asking questions. Ooh, that's a good question. Is it possible to wrap Flask in Uvicorn? Maybe. I don't know. I don't know. So any other kind of server framework would have to be compatible with the ASGI interface. So as long as it's ASGI compatible, then yes. I don't know if Flask is ASGI compatible. Interesting question though. We got another question here. Do we want to do the mic running? Yeah. So guys, when you raise your hand for questions, raise it high so we can see you with the mic. So.
I've experienced with ASGI server, but one server did not support ASGI. It it was where WSGI.
WSDI.
So these types of
W-
service related to related to server itself machine
Yes.
or its operation system.
Oh no, it's not an operating system. So ASGI is almost the same as WSGI. It just supports the async part. Okay, but WSGI is also that underlying server system that handles the HTTP communication and all the socket stuff. Does that answer your question or not really?
Yeah.
Okay, cool.
Maximum of is
Try using the other mic. Sorry about that. Okay. Cool.
the maximum of SGI workers depends on course CPU.
It depends on your application. So if your application is CPU heavy, then yes. Otherwise, you're going to be memory constrained regardless of the number, regardless of how many threads you're running simultaneously. So if you're CPU heavy, yes. If you're memory heavy, maybe not. Is that what you were looking for or something different? Cool. All right, any other questions before we move forward? All right. So you have your fast API framework. You're running it on the Uvicorn ASGI server. Now it tells you, hey, you have to pick a port. The hell is a port? Okay. Who does not know what a port is? Wait, seriously, you all know what ports are? Okay, we got at least one. I'll take that. Cool. So if we use the analogy of a computer being like a house, right? And an IP address is like that house's address, right? It's how you find it on the internet, right? A port is like the apartment number, okay? It's like a door on the building, okay? It's basically some point at which you can access some kind of resource inside the building, okay? So the access point at which you can access some resource on your computer, okay? Now each port is numbered, okay? And when you run a server, the server has to bind to a port. Again, if we use this kind of building analogy, the server, if you imagine the server as a person or maybe a business, right? And you come to the door of the business and then someone opens the door and serves you something, whatever you asked for, right? The server is the person behind the door, but you have to figure out which door do they live in, right? And so that's the port, right? So you bind a server to a port, okay? So let's say I have a big giant apartment building. It has 1,000 doors, right? And I could say, hey, I'm going to bind this server to port 1,000. And whenever someone comes to your computer and says, hey, can I get some data from port 1,000? Then that server process will be like, yes, I'm the one at port 1,000. Here is the response to your request. Versus if someone makes a request to door or to port 999, nothing's going to happen. The door is locked, and they're going to get a connection refused because that port is not open, that door is closed. Okay? So your server has to bind to a port so that other computers on the internet, when they visit your server, they know which door to request to get data from your server. The reason for this is because a computer can have many, many, many server processes. I probably have like 100 on this computer right here, right now, right? And I think I only wrote one of them. Okay, it's just that's how software is. There's a bunch of servers all over the place, right? So by having each server bound to some port, you keep collisions from happening. You prevent confusion, all this kind of stuff. Now there are also common ports for common purposes. For example, HTTP. The standard port is 80. Okay. HTTPS, secure HTTP, is port 443, right? These are things you will just happen to memorize over time, okay? There's a bunch of other ports, like SSH is port 22, Postgres is 5432. I don't know, those are the only ones popping in my head at the moment. But over time, you'll learn what ports are important. Now, one big thing is port availability, because you can only have one process on one port, okay? Only one person can fit in that door, all right? If you have a server listening on port 80, let's say, and another server also listens on port 80, the first server is gonna be like, go the hell away, no, this is mine. And the operating system will be like, no, that port is already in use, you cannot use it, and then the second server will just fail, okay? So you have to make sure that the port you want is available. Another thing, ports under the number 1000 are reserved, okay? On Unix systems, if you want to use a port under the number 1000, you must use super user permissions, okay? But Beej, you said that HTTP and HTTPS were 80 and 443. Those are both below 1000. Yes. If you want to be the main HTTP service on that server, you need the super user's permission, okay? Now, that's more of a DevOpsy thing that we're going to cover on the DevOps side of things, but that's just for your knowledge. Usually when you're doing development, you'll often see ports like 8000 or 8080, right? And this is to get something like HTTP, there's an 8 in it, but it's above 1000. And this way you don't have to be using super user when doing your normal development, okay? So that's why you'll see ports 8000, 8080, or 8888. You'll see these very often. The max port number, I believe, is the largest, what is it, 16-bit or 32-bit integer? I forget. So, yeah, 65,000 something, exactly. So you have plenty of space to choose a port. But does that make sense regarding ports? Any questions about, oh, sorry, one more thing. Firewalls. So I mentioned earlier that, you know, if you try to connect on a computer where there's no process listening on that port, right, the computer will just refuse it. But what if there is a process on that port, but maybe you didn't expect it, right? Or maybe you don't want people on the internet to access that process on that port. This is why we have firewalls, okay? When you get to the infrastructure side of things, you'll do a lot of security configuration and firewall configuration, where you'll be enabling and disabling certain ports, and that's how you kind of manage the security of things. There are many, many different methods of security, but that's one of the more basic ones, okay? All right, so any questions about ports?
Can a server listen to multiple ports at the same time?
Ooh. Yes, a server can listen to multiple ports at the same time. There are many servers that do listen to multiple ports at the same time. So, for example, there's a game I love to play called Ark, and the normal game server connection is on like 27015 or something like that. No, 27010, something like that. And then the admin interface, where if you want to do like admin commands to the server, that's on 27015, right? So in that case, the process is listening to two ports for two different purposes. One is for public normal player traffic. The other is for like private administrative traffic. So that's a common use case for having multiple ports in one server. Does that answer your question? No, go ahead. So the question was, in that case, aren't you running two servers? Yeah.
I'm just thinking one single server process.
It is. So in this case, it is one single server process. So it depends on like how you're defining server. I would say by most definitions, it would still be one server because it's one process on the operating system. It's just listening to two ports. Now, if there were two processes listening on each of those different ports, then yeah, they would be two separate servers. Does that make sense? Cool. Other questions? Great. All right, so on that note, processes and workers. Excuse me. So as I mentioned earlier, there's no true multi-threading in Python. Again, unless they've changed the GIL thing. I don't know if or when that is happening. If anyone wants to look it up, I would love to hear. You can run a server with multiple workers, okay? So I mentioned earlier, you can do this like async thing, right? To basically support a lot more traffic. But maybe you want a greater separation between your workers, right? And also Python is just using one thread, right? What if you have like a 16 core machine and you want to use all 16 of those cores, right? but you don't want 16 different servers on 16 different ports, right? You still want one port, but you want to use all 16 of your CPUs, right? In that case, what you want to do is you want to add more workers, okay? The way this works is you have the server process has a parent process that's bound to the port, in this case, maybe port 80, right? And then it creates a bunch of worker processes. You can have one for each CPU, right? And then you would be using all 16 cores and have each of them be doing the async thing on each core. And that would basically multiply your server's CPU capacity by 16, or your compute capacity by 16, right? If your application is compute bound. If it's memory bound, sorry. Okay. Now, in this case, each worker handles different requests, okay? And otherwise, you still have the same parent process that's just delegating, like it gets a request, it delegates it to a worker, the worker does work, sends a response, the parent process forwards the response back to the client. That's it, okay? Now, this is good to know when you're kind of a smaller operation, maybe you only have one server, and you really need to get as much compute out of that one server as you can, right? And so you do this. But if you're a larger operation, you're probably using Docker, at which point this shit doesn't matter, because you're just going to use one CPU for that Docker container. And then if you want to use a different CPU, you just make another Docker container, whatever. And then you have clustering problems. But that's why we have day 5. Okay. So this is good for small scale operations when you just have one server and you need to maximize your compute. But if you're doing Docker things, don't worry about this. That said, it is still possible to do like a single server configuration where you have one Docker container using multiple CPUs, and then you can still do this stuff. But that seems like a lot of extra work for no reason. Okay. So any questions about processes and workers? Oh, great. All right, so lastly is configuration. When we configure our server, right? Or when we start our server, it needs a bunch of information to know how to start, right? Like maybe it needs to know what port it should be listening on. Or maybe it needs to know, where the database is and how to connect to the database. Or if you're using like blob storage for images or something, it needs to know where that blob storage is and how to access it, right? These are all things that should probably not be in your code. For example, passwords. Should those be in your code? Louder.
No.
Good. Do not put passwords in code. I will find you. Not really. I'm not actually threatening anyone. But keep your secrets out of your code. Secrets do not belong in Git. Okay? So how do you handle secrets then? Configuration. Okay? You can supply configurations that are not part of your code, but that your server can still easily pick up to do its server work. All right? In FastAPI, there's this settings class, which I'm going to demonstrate shortly. And then that can automatically pick up environment variables. All right, environment variables we're going to talk about a little bit more in the 12-factor session. Okay, but environment variables are basically variables just kind of on the computer that processes can just pick up. Okay, and then it does support default values. So it's particularly useful to set a bunch of default values for development, and then you don't have to worry about a bunch of configuration. And then you do proper configuration in production. It also supports type checking, so you can make sure that your configurations are using the right types. So like if you say port monkey, like it's going to be like, no, what are you doing? I need a number. Okay, that kind of stuff. So any questions about configuration? All right, who's ready to write some code? Okay, a couple people. Why not? All right, let's do it. Let's do it. So, nope, that is not the correct thing. Here it is. All right, so hopefully, oh man, let me get my reference up here too. Just a second here. Yeah, there we go. Yeah, that'll work. All right, so let's hopefully you either have the project set up from the last session or you just use the template that we shared in Discord. And you should have a repository that looks something like this. Make this a little bit bigger for you guys. Okay. So what we're going to do is in our app module, we have this main.py file, right? Oh, crap. I don't have time for that. Yeah, we're just going to. So I set up your PyProject.toml to where you have this run script here, okay? And it runs the main function in your app.main module, okay? So I've already configured this for you. So then what this means, this project script, if you did, so once you have all this set up, you want to do, you know, pip install e and then quote dot brackets dev, okay? Those of you here during discussion, I covered this already, but oh man, this is really ugly. Anyway, if you run that, it'll install everything. Here it is again, just for your reference. But don't forget, you need to activate your virtual environment. Don't do that if you didn't activate your virtual environment, okay? Again, activating your virtual environment. There we go. Yeah, let me just move this to the next line here. Yeah, there we go. Okay. That's how you activate your virtual environment if you created it already. Also, these instructions are in the README. So if you look at the README here, you can just grab them. What's that?
Create the virtual environment.
That's right here. This one. So if you follow these, you should be good to go. Okay, so everyone take a moment to get to execute these to get to this point here. Okay. And if you once you've done all this, if you just type in run and hit enter, it should print hello world. Okay. So everyone, please get to that point. Let me know you're good.
What is number main? Don't need it.
This one?
Yeah.
Yeah, it's 2 underscores. Underscore.
No. What does it do?
It allows you to run the module as a program. I don't want to dive into it right now. Yeah, but I do recommend looking it up. It's a nifty little thing. Yeah, but you generally don't need to worry about it. Technically, you don't even need it for this project, but yeah, this makes it nice and easy. It allows you to just do like Python-m app, and it runs it.
Oh, you can run it from anywhere, like not in the folder.
Well, so this configuration here, if pip wasn't so damn strict, you should just be able to do this, thanks to that main file. But pip is really picky, so yeah. Okay. So everyone has it printing hello world, yes? Or something like that? Great. Okay. Now, let's actually get into building our server. So, first things first, if we're going to use Fast API and Uvicorn, we should probably install them, right? So, what we can do is we can basically just copy. We can just copy these guys into here. Okay, so I'll give everyone a minute to type those. Okay, so go ahead and type that into your dependencies in your pyproject.toml. Okay, this will install the Fast API kind of standard dependency set and another library called Pydantic settings, which is going to be useful later on. Okay, so go ahead and add those to your project. And then once you've done that, you can do pip install -e and then this thing again. All right. And please give me some kind of signal once you got these parts done.
855.
Sure. Is that better? All right. Is everyone, a couple people are still typing. Something's weird with my posture. Ugh. Yeah, there we go.
Can I have a short question?
Yeah.
I run the run command and I saw in your my project setting there is a run command setting. Yeah. In the terminal, if you run just like the run, it seems it seems like it's running the hello world.
Yes.
But does the run is the command? It's similar to make.
So I could call this anything, right? I could call this monkey, right? And if I,
Oh, you need to reinstall.
so if I, oh crap. Yeah. And if I install it, it's going to take a minute because it's going to install Fast API. Yeah, now if I do run, it's going to fail because it's like, I don't know what that is. But if I do monkey, yeah. So it just goes based on whatever this is. Does that answer your question? Great. All right, so everyone has these dependencies installed, right? And they did pip install all that sort of stuff, yeah? Everyone's good? Okay. So after that, what we can do is, let me get my reference here, 1 second. There we go. We can now, also, I do this in a very specific way. I don't know how common this is. This is just how I prefer to do it. So there is a bit of opinion going on here, all right? But I'm going to import Ubicorn directly, okay? And then I'm going to, from Fast API, import Fast API. And then I'm going to make an app from the Fast API constructor. And why is it complaining? But I installed it. It's fine. And then in my main, I'm going to do uvicorn.run. I'm going to say run app.main, and then the app object. And then I'm going to set the host to this. I'm going to set the port to 8000. And I'm going to set the log level to debug, just in case something goes wrong. Okay? So I'm going to get that typed out. Sorry, I typed so fast. And then once you have this, you should be able to just run. And then if you see this, then congratulations. If you see this, you're running your first server. What you want to do is you want to add a /docs at the end. And you get this. Okay. Is everyone able to run their server? No? All right, can we get helper? Do we have helpers? Shit. Yeah. All right. Don't forget, guys, you need to, so I think, who else needed help? Okay, in the back there, in the back here. Okay, a bunch of people. Keep your hands raised if you need help. All right, let me help you guys out. What's up? All right, who else needed help? Anyone else need help?
On the dependencies, you don't have Unicode, right? Because I edit.
No, it's included with Fast API.
Oh, okay. But it works. So there are often people running to the Uber knockdown.
Really?
It should be part of this.
We need
Yeah,
to.
there's like at least 3 people.
Okay, then in that case,
You can just throw it into dependencies.
Yeah.
and run it.
yeah. So if you just, for folks running into the Ubercorn issue, just add it here and it should work. Or add it here and then pip install. I must have some kind of dependency solution. I'm sorry. So yeah, if you install Ubercorn and then run, it should just work.
So. There's some weird Linux. There's some weird Linux problem. Give me just a second.
All right, folks, if you're having trouble, also test to see if you can run it this way. If you can just do python-m app, that should also work. Okay. All right, let me have that over here.
Oh, you're making variables. So there's a
All right, anyone else? Okay, so, yeah.
After adding the
Okay. So, all right, guys. We're over time, but we got to finish. Otherwise, you're gonna have trouble later on. Okay. So, now that you have this, let me catch my thing here. Okay. We still need to do the settings, right? I talked earlier about having certain things in configuration because you may want to run your server in different environments. Okay. So what we need to do is in our app module, we need to create a new file. All right, we're going to call it settings.py. Okay. And in the settings.py, we need to, from Pydantic settings, import base settings. Okay. And then we're going to define a settings class. And we can say host address is a string and its default value is 0.0.0. And the port is an integer and its default value is 8,000. Okay. And then just a second here. There we go. And then back in our main, we can do settings from our settings here. Okay. And then I'm just going to use my auto import here. Okay. So from app.settings, import settings. Okay. That's this guy here. And then we're going to set that to a variable. And then down here, we're going to do host is settings dot host address, and port is settings dot port. Okay. And you should have no difference. You should be able to run it again just the same. And then we're over time, and I gotta make sure to give Dennis or whoever's next their time. And call out if you're having issues with this one. Do note that you do need to do the import here. It's not available on the screen here because my screen is, or I guess I can make my screen a little bigger. There we go. And if you make these changes, you should be able to run it just like before. You should see no visible change. The only difference is the host address and the port are now part of settings, which means that we can change them whenever we run the server without needing to change the code. Okay. And I want to try to finish this up in 2 minutes because I'm already 5 minutes over. Everyone good? No one's having troubles? Oh, one. Right, anyone else need help? Nobody. All good? All right, so just to review, in today's session, we covered what a server is. We talked about Fast API as one of the possible backend server frameworks. We talked about ASGI and UVicorn, and in your sample code, we were using both Fast API and UVicorn. We talked about ports. You guys are binding to port 8000 now because ports below 1000 are reserved and require super user. Ports above 8000 are free to use. So we used 8000 because HTTP is port 80 and 8000 is close enough. And we talked about processes and workers. It's not super relevant for today's work, but it could be useful if you're working at a tiny startup with no budget in the future. And we talked about configuration, and then we actually updated our app to use configurations so that later we could convert those to environment variables to allow us to change configuration at runtime if we need to run the server in a different environment or something like that. Any final questions before we end this session? Yes?
Can we trigger pre-commit hooks without actually committing?
Can you trigger pre-commit hooks without actually committing? Yes, you can. So you can do, where's my terminal? You just do pre-commit, run. Run. There we go. Just do pre-commit run, and it does it. But you have to have stage. Yeah, so you have to add everything, get add, and then pre-commit run. And now it'll run on the stage files. You'll see it rearranged my imports already for me. And now if I run it again, oh no, is it having one of those weird loops? Oh no, what is happening? What is this? Wait, why, what? Interesting. Huh. Well, crap. Okay, I'm gonna fix that issue and let you guys know.
I did work on it.
Oh, works for you? Okay, must just be my environment. All right, any other questions? Great. Well, thank you very much, everyone. I apologize for going over time. But yeah, I hope that congratulations on running your first server. All right, moving on to the next person. Who even is next? Is Dennis. Okay. I will go fetch Dennis. Oh, he's right there. Great. All right, I'm going to disconnect here.